Okay, good morning, Wednesday, October 7th, 7:19 a.m. here. So getting ready for you guys to join us here in class. All right, so let's go ahead and go through today's notes. It's 2.3.1, which is arithmetic and geometric sequences. Just so you're aware, sequences are a list of numbers with a particular pattern. We will be discussing two types of them. All right, so what is the pattern below? If you take a look, let's go ahead and create a table and help determine how many dots will be in the 10th image. Okay, so this is image number 1, 2, 3, and 4. 1, 2, 3, and 4. In image 1, there is 1 dot. Image 2, there is now 5 dots. Image 3, there is now 9 dots. Image 4, there is now 13 dots. Okay, and so 1, 2, 3, 4, 5, 6, let's see here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yeah. Okay, so what is happening? What's the pattern that you see below here? Right? So if I add 5, 6, 7, 8, 9, we could go all the way up to 10. Okay? Well, as you can see, we are adding 4 to each one. So this would be 17, 21, 25, 29, 33. So that means in the 10th image, there would be 37 dots. Okay, use the table above to graph each point. So what we're going to do is just take these as an X and a Y as an input and an output. And we're just going to do the best that we can to do this. So 1, 1 would be here. 2, 5 would be here, right? Let's see. 2, 1, 2, 3, 4, 5. Good. And then 3, 9. So add 4. 1, 2, 3, 4, and over. Add 4 and over. 1, 2, 3, 4, and over. 1, 2, 3, 4, and over, etc. Okay, and so you can see that this is what type of graph? Right? You can see that it's linear. Okay. So an arithmetic sequence is a type of linear function. All right. Oh, I forgot you're not really supposed to draw a line, but it is a linear function. Okay, so what is an arithmetic sequence? It's a type of function where the y values increase by what's called a common difference. Okay, the common difference is a blank that is being blank or blank to the previous term to get the new term. So it's a number that is being added or subtracted, you'll see, to the previous term to get the new term. So all that means is we went from 1 to 5 to 9, right? So our common difference up above, and it's labeled D, as you can see the letter D. Our common difference up above would have been a +4 because you're adding 4 each time. Okay, let's take a look at geometric sequences. What do we notice about the pattern? Well, let's go ahead and write this down. So at the beginning, okay, how many minutes? 3, which is up here. 1, 2, 3. Next one, 1, 2, 3, 4, 5, 6. Next one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so just looking at this, okay, actually it should be like this. I'm sorry, 0, 1, 2. It says at the beginning after 1 minute. So when 0 minutes have passed, that's why this one's a little bit different. So this would be 3, 4, 5, 6, 7, 8. Okay, what's happening right here? What's doubling, right? You're multiplying by 2. So at 3 minutes, it'd be 24 and 48 and 96. And what's that? 192. And this would be 400 minus 16. So it'd be 384 and 768. So, right? 768. Okay. So use the table above to graph each point. So 0, 3 starts here. Okay, 1, 6 goes up to 3. 1, 2, 3. 2, 12 goes up 6. 1, 2, 3, 4, 5, 6. And 3, 24 goes way up here somewhere. Okay, so as you can see, it kind of looks straight, but it's actually going to take a curve and take off almost exponentially. So geometric sequences are a type of exponential function. okay? A type of function where, in a geometric sequence is where the type of function where the y values, so y values again, this is the difference, by a common, and this one's not difference because you're multiplying, so we know it as a common ratio. The common ratio is a number that is being multiplied, always multiplied, okay? This one's a little bit different. We're never gonna say like, oh, D, it's being divided, so we're gonna say it's divided by 2. Because when you say it's multiplying by 2, it's the same thing, right? So if it's being divided, you're always gonna say what it's being multiplied by, which would be the fraction, okay? So this would be like 1 to 2, 4, 8. This would be 8, 4, 2, 1, right? You're dividing by 2, but you're really multiplying by 1/2. All right, so let's go through some examples. Find the missing terms in the arithmetic and state the common difference. Goes up 6, goes up 6, so this has to be 17. 35, common difference was 6. How about this one? Down 4, down 4, down 4, down 4, down 4, common difference, -4. Same thing here. 7, it goes up 7. Okay, so this must have been 2, and this has to be 30. Okay, how about this one? Plus 0.75, plus 0.75, so that gives you 3.25 and 4. Okay, how about here? Find the common difference or slope of the following functions. So this goes up 5 over 1. So the common difference here, 5. How about this one? This is a 1, goes up to 4, so that's plus 3 over 1. So this is 3. 3 over 1, which is 3. Okay, this was 5 over 1, which is 5. Okay, find the common ratio for each geometric sequence. 2, 4, 8, 16. So the ratio, how is this changing? It's times 2. How's this one changing? 10 to 5, 5 to 2.5, 2.5 to 1.25. It's times 1/2. So the R is half. It's dividing by 2 every time. Okay, how about this one? Not a geometric sequence, right? So this actually should have been probably up above, but that's okay. So since this one's adding or subtracting, this would be a common difference, not a common ratio. Okay, but this one's multiplying, times 3, times 3. So this would be 81, this would be 243. So that would be a ratio of 3. This one is the opposite of that exact one, so it's dividing by 3, so this would be down 1/3. Okay, which would give you 1 and 1/3. So this is a ratio of 1/3. Okay, lastly, a couple here. Look at the y values. Okay, always look at the y values. 3 to 6, 6 to 12, 6 to 24. So this is times 2, so that would be a ratio of 2. This one goes from 1 to 1/2 to 1/4, so that tells you the ratio here is 1/2. Okay, so lastly, before you get to the exit ticket today, find the missing values in each sequence, determine if there's a common ratio difference, and state what it is. This one goes up 5, so this would be 20 and 35, which means since it's adding, it's a common difference, which would be plus 5. And since it's a common difference, that means it's arithmetic. How about this one? 20 to 10. Ooh, so that's either down 10, but look, if I go down 10, that would be 0, and that would make sense right there, right? So this has to be dividing by 2, which means this would be 1/2, which 10 divided by 2 is 5. 2.5 divided by 2 is 1.25. So this is a common ratio of 1/2, and it is geometric. This one's adding 3 every time, so that would be 11 and 17, which makes it a common difference, plus 3, arithmetic. This one is minus 6. If we did minus 6 again, it would be 18. That's minus 6. Okay, cool. So that's a common difference. So this would be minus 6, which means it's arithmetic. Okay, that's it for today. Go ahead and complete the exit ticket. Ask questions here in class or tomorrow when you get back to class if you're Group B, and I will see you guys soon.